Here's the question then. Lots of different parts. There's A and B. Here's C and D. And here's E and F. So I've got the question summarized over the page here. Tried to squeeze it all in. And I'll try and work through it on the page itself as we go down the question. So L1, find AB. So here, the first part AB, then squeeze it in here. Here's the vectors. So it's -1 minus -2. It's 1. 3 minus 4. And 8 minus 7. So there's AB. Line L1. So R is equal to -247 plus lambda 1 minus 1, 1. So there's the line. OP is this. PBA is theta. So you've got OA. Then you've got OB. And then there's AB. P is 023. We want PBA. So there's P. Angle PBA. Oops. So there's a little sketch of the vector. There's OA, there's OB, there's OP. And we want to find out angle PBA. So this angle here. So we'll need BP. It's a vector. B to P is 0 minus -1, 2 minus 3, and 3 minus 8 is that. So it's 0 minus 1, minus -1, -1, minus, I'll get it right in a minute. 0 minus -1, 2 minus 3, and 3 minus 8, that's right. And we need BA is equal to, BA would be -1, 1, -1. The other way around from AB, isn't it? Okay, so the dot product then. So cosine theta will equal the dot product over the product of the moduli. The dot product, I'll just do it, try and save some space and do it in here. The dot product would be -1, -1, and that's a minus, isn't it? So that's +5. And the product of the moduli, 1 squared, 1 squared, and 5 squared is 27, square root 27. And this is 1 squared, 1 squared, and 1 squared is the square root of 3. So we end up with 3 over 9, which equals 1/3, which is what we wanted to show. So that's part C. L1, L2 passes through P parallel to find L2. So D, L2 passes through P, 023, plus mu, parallel to L1, so it would be along AB, won't it? 1 minus 1, 1. Given AB equals PC, AB equals PC equals DP, find L2. So L2 passes through P parallel to L1. So here's L2. And AB is PC C and D lie on L2. Given AB is equal to PC, so I'll put C there, is equal to DP, put D there, and the x-coordinate of C is positive, find OC and OD. So these are the same distance either side of P as this length here. The modulus of AB is root 3. I'll put it here. We worked it out before. So basically, we're going to have the L2 line. It's going to be a distance root 3. So mu will be 1. It has to be because this distance then is root 3. So for E here, mu equals plus or minus 1, because this distance then away from this would be root 3, wouldn't it, if you think about it? So mu has to be, because that distance vector is root 3 times 1 modulus wise is root 3. So the vectors are, if you put 1 in here, you get 1, 1, and 4. And that would be C. And minus 1, you get minus 1, 3, and 2. And that would be D, wouldn't it? Because C had the positive x vector. Okay, find the OC and OD. Now, the area. D. Okay. Find OC and OD. Find area ABCD. AB and then CD. So that's parallel to that. Oh, area ABCD. Bop. Bop. Okay. So, okay. Right, well I'm going to draw this out a bit better. So you've got AB, you've got, you've got AB, then you've got there, and then you've got that line there, and that line there. P's there, right, and then you've got C, say, and D, AB. Okay, this is the same distance away from here. This angle here is theta. AB is root 3. So this distance is root 3. This distance is root 3. Because we said about that, didn't we? What else? Okay. So if you drop a perpendicular here, this height would be root 3 sine theta. So they've all got the same heights because it's parallel lines. So area, 3 lots of half base times height, which is 9/2 sine theta. Cosine theta is a third. So sine theta would be the square root of 1 minus cos squared, which is 8/9 square root of, which is 2√2/3. So we end up with 9/2 times 2√2/3, which is 3√2. That's the third form. Yeah, I got a bit of a mistake here, I think, because this simple little triangle thing, I've just looked and thought about the question here and looked at the solutions is always helpful. I think everything else is okay, but there's one slight error here, and I just made the mistake of this height. Just doing it too quickly. Because tan theta will equal the height over the, that whole side's √3. Ooh. Okay, this is tricky then, isn't it? So, P to AB, I wonder what this is then. Okay, these two lines are parallel. P, L2. Yeah, that was fine. Okay. So this side here, I'm just wondering what length of side that is. I dropped the perpendicular and assumed symmetry, but that would assume that these two sides should be the same distance. So, I'm just wondering if that's the case. Might not be. Okay. So what we need then, if you think about it, we need this height distance here, the distance between the two parallel lines. We know P has coordinates. The distance PB is what I want, which we worked out before. PB was √27. Here, 25, 26, 27 is √27 is 3√3, isn't it? If you square that, you get 27. So it's 3√3. So this side here is 3√3. This is theta. This will be a 90 degree. So, and we've got parallel lines here. So this angle here is theta, isn't it? So this is 3√3 sine theta, this height. H is equal to 3√3 sine theta as far as I can see. Okay, so the area would be, instead of √3 sine theta, which I had before, it's 3√3 sine theta. So it would be times by 3, 27 over 2, hopefully. 27 over 2. And this would be 27. And that would be 9√3. 9√2. Just scaling it by 3. Because the height was 3√3. Hopefully that's okay now. Yep, that looks good.